Hello out there to you. We've got this problem set. We've got a cost schedule. In the cost schedule, we've got output using labor as our input. And our output is here. We've got fixed cost, variable cost, total cost, marginal cost, average variable cost, and average total cost. So we need to fill in the table, answer some questions to think about. Assume the only variable cost of production is $100 per day, which is for the labor. Okay, so we're going to copy this table here, output, and then cost functions. Okay, we got L, we got output. Sometimes they write that as Q. Okay, 1, 2. Here's a trick with Excel. Once you tell Excel there's a pattern, you just highlight everything and go all the way up to 8 workers. And our output is, looks like it's not linear here. 75, 75, 70. Okay, our cost functions, FC for fixed costs is 200. So what we know about fixed costs is that in the short run, they do not change. So actually, I can just copy 200 all the way down. They're not going to change based on production. Variable cost is going to change. So when I don't produce anything, this is being shut down. But then the variable cost here, the only variable cost is labor, which is $100. So I'm going to write a function here, which is equals, hit equals on your keyboard, the labor units or workers times 100, because that's the wage. Now, if you wanted to, let's do this actually. Let's type in W equals, let's actually write a formula here. And I'll show you why I'm doing that in a second. So equals this, and I don't want that to change, so I'm going to put dollar signs in front of it. It locks the cell. And then I'm going to multiply that by the number of workers. Okay, I'm going to copy that down. And the reason I'm doing that is, let's say that the wage maybe increased to 125. I can just change it there, and it'll update my variable costs in my spreadsheet. Okay, so you can change that to whatever you want. Makes it pretty slick there. Next, let's also make these centered. I just like the way that looks. Total cost, marginal cost, average variable cost, average total cost. Now these three don't have a value when we're at 0, so that's why you see the dashes in the table. So, and average variable cost is just the variable cost divided by quantity. So we wouldn't divide, you couldn't, it's undefined if you divide by 0, so we wouldn't do that. Same thing with average total cost. All right, so total cost is, in the short run, is going to be fixed cost plus variable cost, and we'll just copy that formula all the way down. Okay, marginal cost is the change here. I want this to look like it looks on the table there. Merge and center. Okay. Marginal cost is the change in total cost divided by the change in output. So I'm going to write a formula. So it's this minus this, and then divided by, and I put it in parentheses because I wanted to do that first, divided by this minus this. So put this here, okay. And so it makes sense because that's a difference of 100 divided by 10. 100 divided by 10 is 10. So we'll just copy this formula all the way down. It doesn't like this one. So when you get here, the reason is because we're dividing by 0. So in my opinion, it's kind of a judgment call, but I'm going to just put it at 20. Okay. Now, right here, did it actually get cheaper? Not really. So what we probably want to do is write the formula in absolute terms. So we can do this if we tell Excel in absolute terms. There you go. I just copy that formula all the way down there. It didn't work for some reason, so I'm just gonna outsmart it here. I'm gonna put oops, I'm gonna just change this to 20 because we went up by 100. We didn't change the output at all, so it makes kind of a goofy number. But we'll say that that's 20. All right, we're gonna multiply this just by -1. Okay, because we want the cost to be in positive numbers. Okay, so this is 6.67. Okay, now average variable cost, we just take the variable cost and we divide it by the output. Okay, get this, and got all of that, and then average total cost, we got total cost divided by the output. That coming all the way down there. Okay, and now I've filled in all of the numbers. Okay, now the question, of course, is what does it mean? If the prevailing market price of output is $5, so they're going to sell every unit at $5, tells us it's perfectly competitive. What is the profit maximizing output? So the answer to that is I'm going to produce up until marginal cost equals $5. Okay, because if I produce more than that, I'm going to start to lose money. Okay, so I'm going to produce 45 units because that's where marginal revenue and marginal cost equal each other. Okay, if I produce more than that, I start to lose money. We can actually prove this if we do total revenue and then we do a column for profit. Okay, with Excel we can do this really fast. So total revenue is output times price, which I want to give it a price up here. So price equals $5. Okay, so I'm going to multiply this, and I'm going to lock those cells. I hit F4 on my keyboard. So I'll lock the cells, and then I'll multiply it by the output, and that's going to be 0, of course, because I didn't sell anything. Copy this all the way down. There's my total revenue, and then profit is total revenue minus total cost. Okay? So remember what I said, profit maximizing. In other words, the most profit we're going to make is if we produce 45 units. So let's see what happens when we scroll down here. So we're always losing money. Okay? This is not a good enterprise. In the long run, I want to exit this market. So the best I can do is to produce 45 units and lose $275. Okay. Now, if you look, if I don't produce anything, I can actually what's called shut down and produce a -200. So I actually should shut down because the price is below. Really, it's below, and you can see it. It's below my average variable cost. Okay. So, all right. So let's answer some questions here. So, profit maximizing output in number 2. What is the per unit cost of production? So that is right here. Per unit cost of production is $11.11. That's the average total cost. What is the per unit labor cost? Okay, so that's going to be our variable cost. That's $6.67. The rest of that must be fixed cost. What is the per unit profit or loss? So per unit, I'm going to lose the difference between average total cost and the price that I sell them at. So $6.11 is the difference between those two. What is the total profit or loss? It's -$275. And if it profit maximizing output, we already did that. Okay, show your answers graphically so you can graph all this in Excel. Lots of videos on that. So we won't take time to do that in this video. In the short run, if the market price is $5, should this firm continue to operate or should it shut down? It should actually shut down because it can earn a loss of $200 if it shuts down versus if it produces. The best it can do is lose $275. So you can say it that way. You can also just explain the shutdown rule. The price is below average variable cost, so the firm should not produce. Okay. If the prevailing market price is $20, what is the profit maximizing output? Okay. So we're just going to compare that to right here, and so then it would be 75. Okay. So 75. That marginal cost equals marginal revenue at 75 right there. profit maximizing output number 9. What is the per unit cost? So it is $10.67. The per worker cost is $8, so this is a much better deal. Total profit or loss, okay, so we're just going to change this to 20 now. Okay, so now best we can do is 700. Okay, so that's just changing this number up here, and since we had that set there, it's going to update here and update here. Okay, it won't change any of your cost information. Let's see, what is the minimum price needed to break even? So what we're going to do is just look at this column here, and the price is going to need to be at least $10 to break even. If the price goes above $10, then we can start making a profit. If it goes way above, 12 or 14, we can start earning a profit there. Okay, that's how to solve that type of